So let me start with some motivating facts. Here the blue line is the employment to population ratio in deviations from HP trend. Now there has been in the United States. Okay, so there has been a large literature trying to explain the extent, the magnitude of fluctuations of these variables in the US. There has been, though, less much attention about another property of this series that is like if you see the deviations below trend are in magnitude larger than deviations above trend. Okay? So this is an asymmetry between trough and peaks. Okay? Now, this paper is going to be trying to understand what are the driving forces behind this asymmetry between peak and troughs. And now we know that we can rewrite the employment to population ratio as 1 minus the unemployment rate times the participation rate. Okay? So here I'm showing you the red line, the red dotted line, what I call the employment rate. This is 1 minus the unemployment rate. Okay? As we can see, the unemployment rate over the business cycle tracks pretty much the employment to population ratio. So therefore, we can see that 1 minus the unemployment rate is pretty volatile over the business cycle. And again, there is this property that the deviations below trend are larger than deviations above trend. If you look instead at the participation rate, we all know that the participation rate is much less volatile over the business cycle. But the new fact is that actually the participation rate moves symmetrically over the business cycle, right? So the ups and downs are pretty much symmetric. So it seems to be the case that there is this disconnect between the unemployment rate, how it moves over the business cycle, and the participation rate. Okay? So the first steps that we do in this paper is try to write a theory where we have unemployment and endogenous participation, trying to make sense of these facts. And then we're going to use the theory to derive some implications of the asymmetry over the business cycle. Okay?
You have like a measure of the asymmetry that you can...
Yes, here. Okay? The question. Okay, so just, I knew it was coming. So just to be precise about, so just to give you a simple statistics, right, that gives a sense of this asymmetry. Here I'm plotting in this table I have the skewness of the employment to population ratio. This is the 1 minus the unemployment rate, and it is the participation rate, right? With different filtering and trending methods, what you can see is that basically this asymmetry between peak and trough in the employment to population ratio, what it's doing is generating negative skewness in the EPOP. Now, consistently with the graph, you can see that you see negative skewness in the employment rate, but there is basically no skewness in the participation rate. Okay? So this is going to be the key statistics that we bring to the table. Now, just as a side note, we are not interested in the third moment of skewness per se. Right? We are interested in skewness because I think it's a nice statistic that captures the features that I was hinting at in this slide. Okay, so what you
do it after the 80s, you get the same thing?
I get the same thing. Now, after the 80s, there's also another asymmetry that I think that the literature has talked a lot about, what so-called jobless recoveries, but that implies an asymmetry between the behavior of output and the behavior of employment. But we are not going to talk about this in this paper. But these facts that I showed, these statistics that I showed you, they are more or less the same before the 80s, from the 50s to the 80s, and after the 80s. Okay. So what do we do in this paper? What we do, we just build an equilibrium business. So the logic is the following. Now, I was about to say it here, but no, let's say it now. So, Victor, a standard approach in business cycle is to, if you go back to the RBC, the view about the business cycle is that the deviations from trend are symmetric. Now, this implies... But let me conclude, Victor. So, in a world in which the fluctuations are asymmetric, as I was showing you, what happens is the volatility of shocks has an effect on the average level of the employment to population ratio around which the economy fluctuates. Now, I'm going to use the theory, I'm going to parameterize the to match.
I don't understand the logic. Is it that you say I'm going to have a model that is perhaps a metric ex-ante, but it will have a little bit of a memory or a little bit of hangover put in there that may make
Okay. No, fair enough. So the way I was viewing the problem is the following. It seems to be the case that most of this asymmetry, if not all, is coming from what is measured as unemployment. So my first reaction was that it seems to be the case that you need a theory that formalizes the idea that there are people searching for a job that are not working. That led me think that, okay, we need a theory of unemployment. Okay. Now, the second fact about the participation rate that is symmetric, then I thought that would be the disconnect between unemployment and participation would be actually give us a lot of information about what are the driving forces that the theory should have. And that led me to think that I need an endogenous margin of labor supply. Now, once I...
That's fine.
Okay,
Fine.
so once I have that, the model is going to tell me what is the mechanism that generates this asymmetry in that employment rate and the lack of it in the participation rate. And then I'm going to use the model to quantify the effects that I was telling you about. That business cycle fluctuations do have an effect on the average level of employment around which the economy functions.
So it's standard to say in a simple world where these two things can be moved, perhaps for the same or for different reasons. I said in a world where you could have people being moody about how much they want to work and production opportunities moving stochastic, you want to know what does it have to take to generate that differential behavior between these two things. So you're going to search for the properties of shock.
Okay, oh, fair enough.
Is that what you're after?
Yeah, so I'm after, you're going to see. So I'm going to have shocks to productivity that are standard AR1 shocks in logs, so they are symmetric shocks. And the way the model is going to generate the asymmetry in the unemployment rate is going to be through the curvature in the meeting technology. But now I'm going to head on myself. If you think of a standard search and matching model, and you think about you have a curvature in the matching function. Once you calibrate the search and matching model to match the volatility in the data, what happens is that the model is going to leverage a lot on the curvature in the matching function. So you're going to have that the movement of the job finding rate in response to shock is asymmetric. The job finding rate falls much more during recession, falls much more in response to a negative shock than to a positive shock. That intuitively gives this asymmetry in the unemployment rate. The story about the participation rate is trickier because you're going to see. I'm going to have a model in which there are endogenous flows across all the three labor market states, and there seems to be the case that in order to have symmetry in the participation rate, it must be the case that the flows from employment to out of the labor force are such that they compensate the flows from the out of the labor force into unemployment and then employment. So that would deliver the symmetry in the participation rate.
Okay, so the model is going to highlight what are the
Exactly.
what kind of flows that are needed.
Exactly. Exactly. No, perfect. Yeah. Okay. Now, that's what I was. So what I'm passing to say here. What I like about this parametrization is that, and this is indicated to what I was telling you, is that the negative skewness or the lack of it in the model is not in the data is not hardwired in the model. What I mean is that there are parameter configurations in which the model delivers completely counterfactual implications for the participation rate. Like you see positive skewness in the participation rate, but the model tells you that that's because you are missing the volatility of some flows or the co-movement of some flows. It's once you take a stand that the model has to match the co-movement and the volatility of some transition rates that then you restrict the model in order that delivers the asymmetry in the unemployment rate and the lack of it in the participation rate. Then once I do that, the model tells you that the way you generate asymmetry in the employment to population ratio, as I said, is because basically the model tells you that the economy responds asymmetric to symmetric shocks. Now, what does this imply? Of course, this implies that volatility is going to have reduced the average level of the employment to population ratio around which the economy fluctuates. Okay? So I'm going to use the model to measure how much the volatility observed in the US has reduced the employment to population ratio in the data. It's going to tell us that if we shut down the volatility in the employment to population ratio that we saw historically in the data, the employment to population ratio will be 0.3 percentage points higher. Okay? Now, I'm going to call this effect of volatility on the average level scar, okay? Just to find a fancy word that we can easily remember. Now, an implication of this, and this is admittedly the last bullet point, this is still a part of the paper that still needs some work. We're going to say, suppose you have a simple tax rule that moves countercyclically over the business cycle. So a flat labor tax goes down in recession and goes up in expansion. This, by dampening fluctuation, is going to lean against what I call the scarring effect of business cycles. So it's going to increase the average level of the employment population ratio. But as I said, I think this bullet point, this is more like some cute exercise that we did, but more work must be done here.
You should call it post-control tax rule. Because taxes go up and boom.
Yeah, fair enough, fair enough. Yeah, fair enough. Now,
can you show us whether productivity, which is your underlying shock, is itself skewed or not?
It's not. If you look at labor productivity in the US, you can think of employment divided by hours, or by output divided by hours, and output divided by employment is pretty much symmetric in terms of deviations from trend. Okay. There are other asymmetries in the labor productivity, but we're not discussing that in this paper. But for now, just think about that the driving force is symmetric, and we are thinking about the labor productivity here. So as I said, what are the key ingredients of the theory? So this is something that I told Victor before. So we have search frictions that gives us an employment. Then we have individuals heterogeneity in the value of leisure. And that is going to give us an active labor force participation margin. And it's going to give us that all the flows across all the three labor market states are endogenous. And then we're going to have aggregate uncertainty in terms of shocks to market productivity. And then we're going to have some idiosyncratic uncertainty in terms of shocks to the value of leisure and shocks to the job destruction rate. Okay. So what are the agents? So there are individuals and employers. Individuals are infinitely lived. There's a unit mass of them. They are heterogeneous in their valuation of leisure or non-market productivity. They are either employed and producing output, or they are unemployed and searching for a job, or they are non-participant and enjoying the full value of leisure. The employers are, again, infinitely lived. There is a continuum of them that is determined in free entry equilibrium. They are either, of course, either matched with an individual as so producing output, or they are unmatched at posting job vacancies. Now, preferences of the individuals. Here I'm using the notation of the homework in macroeconomics paper. So individuals have a linear utility in market consumption and non-market consumption, and discount future payoffs at rate beta. So what is market consumption is 1 minus tau, the W is the wage, where tau is a tax rate. For now, think of the tax rate as fixed. When we go to the policy experiment, this is going to depend on the stochastic properties of the shocks to productivity. But from now on, think it is fixed. The wage is going to be determined by Nash bargaining. So 1 minus tau times the wage if employed, B if unemployed, and 0 if non-participant. Okay? So what is the consumption of non-market consumption? Is 1 minus h times x if employed, where x here is the value of leisure. Okay? So what we are saying is that if you are employed, you lose a fraction 1 minus h of the value of leisure. Okay. And if you are unemployed, you lose a fraction 1 minus a of the value of leisure. If you are non-participant, you just enjoy the full value of leisure. So here then the basic trade-off in terms of the individual is just that basically if you work, you lose a fraction of the leisure value
So
that you
it's
get
leisure-
otherwise.
You're mixing the word leisure and non-market.
I agree. That's
And then and they're perfect substitutes. I mean, there's like a home production literature that says, on average, they're gross substitutes with elasticity of substitution 2. Nobody gets infinity. Maybe some people get 2.5 or something.
So that's a fair point. I think we are already thinking about introducing curvature in the utility function, allowing for a parameter that governs the degree of substitutability between the market and market consumption. We are not there yet. Here we're just thinking, basically we are keeping the linearity assumption that most of the search literature does. But I'm with you. I think more work should be done.
I
Right?
guess it also, with these linear things, suggests unemployment's not even that big of a deal. I get unemployed, I just produce the stuff in my house.
But that will be the same also for that point is fundamentally there. But even if you allow for curvature and degree of substitutability between market and non-market
I
consumption.
agree, but if there are 2, then it's a lot.
That's not true. There's a bunch of people with a bad X that lose a job, and then they go to consume 0, or they go into a corner and would love to have a job and they don't. Depends who gets a job and who doesn't.
There is uncertainty, right? I mean, there is a level of uncertainty at the individual level that you need to take to. No, in a sense.
The problem is that
No.
I guess I'm
on the clear path, not the right people are not always working.
Exactly. Yeah.
So X is like,
No, but
but it's a home production shock, I guess. You cause the, so a low X person can't produce a lot of home production.
yeah, that's yeah.
I see. That's why unemployment's bad.
Yeah.
So you haven't said how it's X. Is that an attribute of people that is constant or is it
No. X is going to be stochastic. Yeah. Give me one slide, Victor. Okay, it's going to be stochastic. Actually, because the stochastic property of that X are key to get the right co-movements of some transition probability that are very hard to explain if you only have aggregate shocks. Okay, so the production, the usual assumption, you need a match between one worker and one employer to produce output. And upon the formation of this match, output is Y, so an output follows an AR1 process in logs. Okay? And this is going to be the driving force of business cycles. Okay? So a stochastic variation in Y in the output of a job is going to induce recession and expansion. Okay? So we assume that this process is symmetric, and then we see how far can we go through the model to generate the asymmetry or the lack of it that I was discussing at the beginning of the talk. David?
Good. Yeah.
Okay. So usual stuff here. So now heterogeneity in X is key to generate distribution of workers across the 3 labor market states. Now what we're going to assume is the following, is stochastic. We're going to assume that the value of X changes with probability lambda. Okay? So with probability 1 minus lambda, the individual keeps the same value of X that he has now, currently has. With probability, this is 1 minus lambda. With probability lambda instead, it draws a new value of X from a log normal distribution with mu X and sigma X.
There are rules of behavior in the profession. Okay, one of the rules of behavior in the profession is thou shalt not mix preference and technology.
Once again?
And there are rules of behavior in the profession, and one of them that was taught with certain brutality says thou shalt not mix preference and technology. and I see a Y affecting the lambda. And I said, the least you can do is to owe us an explanation.
So, so when I told you that the stochastic properties of X are key to get some facts, that I was hinting to. Suppose you drop the Y here. Okay, so you have that lambda is constant. Now, the model is unable to get the co-movement between with output of the transitional probability from employment to out of the labor force and to unemployment to out of the labor force. Now, in the data, the probability that an individual goes from employment to out of the labor force goes up in a boom.
That's true. If you break it up by men and women, it's all coming from women, and it's all coming from women who have good earning spouses who are just about to have a kid.
So, who just about to have a kid?
Yeah.
Very much a household.
No, so we were discussing with Giuseppe about this, and I think we were actually thinking that perhaps one way to a much deeper theory than allowing the shocks to depend on Y is to model the household and to have these added worker effects that during booms there is a choice within the household between man and woman who stays at work or not. I completely agree. We are not there yet. But going back, there is this puzzling fact that
I think it's better to tell us what happens to us without a Y, and then say magically you put it, things behave.
Okay.
That's the thing. That's rather than
Fair enough.
trying to sneak it
no.
somewhere.
Come on, Victor, sneaky. I say it lambda here.
It's a central property of your findings.
No, it's not. No, actually, no, fair enough.
Why
So,
don't you just call it home production productivity? You're kind of mixing these words. A few minutes ago, I thought you had me with X as a home productivity shock. You get a bad X draw, you can't produce anything at home. I thought you said yes, that's the right interpretation.
yeah, but
So then this is just a technology shock for home production.
yeah, but what I'm saying is that technology, it seems to be the case that to match those the co-movement of those two transition rates with output in the data, you need a technological process for at home must share some property of the technological properties on the market. That's the only point that I'm making here.
Okay, but then you check the box of not mixing technology and preferences. You
Yeah.
put some correlation in home and market
Fair-
productivity shocks.
okay.
Okay.
Fair enough. Fair enough. So, but
So, can you go on a slide now?
slide back
Yeah, back.
here.
One more.
Oh, okay. Here.
Yeah, that one. So you just prove I'm going to say checks.
Yeah. It's the
It
same.
looks like a preference shot.
But that's a well-known. I mean, guys.
another problem,
Sorry,
which is what
sorry,
the
guys.
technology-
Okay, guys. So I agree with David that I would have saved time in using the wording production at home versus production on the market and discussing about technology instead of preferences. We all know that in this environment are the same thing. So let's go ahead. Okay. But I'm going to be more precise exactly what this gives me, Victor. So just wait. Okay? Now, the part about meetings within employers and search is standard. So I'm going to assume there's a constant return to scale meeting technology. That is, the meetings depend positively on the number of people searching, S, and the number of job vacancies posted. Alpha and chi are parameters. Now here, there is one key deviation from the standard model of unemployment that allows us to endogenize the flow from out of the labor force to employment. Okay? So what we're going to say is that who is looking for job are the unemployed guys, and these are paying the cost of searching. Okay? So these are the guys that, since they are searching, they lose 1 minus a fraction of value or leisure. Okay. Now, what we're going to say is that there is, with probability phi, people that are not participant are drawn into the pool of unemployment. Okay? Now, these guys are not paying the cost, the utility cost of search.
If you do it, you say it because you want them to have jobs or you want them to be counted as an employee, which one of the two is?
We made this extension to have a flow from out of the labor force to employment.
So you're not going to change how they're counted.
Exactly. No.
But I mean, if you just did like a, do you think it's really this, or is in the data it's time aggregation, that those people were really unemployed for a while, but you know, between the 12th and the 12th, they don't see it?
Kurt, I know.
No, I'm just wondering.
I know.
I'm wondering if
I think, you know,
yeah.
there is, of course, some issue about time aggregation. You know, we wish to sample people, every day. We don't. But there is a case in which I truly believe, even if you think about month-to-month transition, there are people. Actually, the flows in terms of magnitude are big from out of labor force to unemployment. Are not as volatile as the other flows, but the levels are large.
Just one clarification. So the individuals then choose whether they want to be unemployed or not in the labor force?
Yes. Yes. At the beginning of the period when shock realizes, every guy is going to decide, do I want to incur the cost of search? If yes, then the guy is classified as unemployed. If not, he's out of the labor force. Now, this is standard stuff. So the probability that a job seeker meets a job vacancy is increasing a concave in alpha. And Victor, when I was telling you at the beginning, at least intuitively, what could give the asymmetric response in the unemployment rate is that through this concavity, the probability that a searcher meets a job vacancy responds asymmetrically to the shocks because of this concavity. Now, this of course depends how much the model used that concavity. In the sense that if you have you must have a model that matches the volatility of unemployment in order to move a lot along the curvature of this function.
I thought that's irrelevant when you have free entry. Free entry makes it as linear as you want. Because free entry of firms, so vacancy creations can make that linear. So isn't that mentioned free entry condition that makes the unemployment not to be a state variable?
No, that's what I said.
Actually, the vacancy, the curvature doesn't really matter as long as enough vacancies are created for a given amount of unemployment.
So here we preserve the same feature of the standard DMP, where you have that the unemployment is not a state variable of the individual problem.
So that curvature really is not that relevant when you have free entry of firms.
Honestly, Victor, when you calibrate the model as we do to match the volatility of the employment to population ratio, that curvature matters a lot. Now, hopefully I did a good job in describing the environment. I don't have to spend too much time discussing about the Bellman equation. So here, guys, I'm using the notation omega. This is all the aggregate state variable. So think about the y, the shocks to productivity, and you can also think about the tax rate, even though until I get to the tax rate is going to be constant. So what is the value of a field job? Is difference between the output on the job and the wage. That, as I said before, is going to be determined by Nash bargaining. And then with probability 1 minus delta, the jobs is not destroyed. So guys, delta is the shock to the job, is the job destruction rate. Okay? Then you have the max between the value of the field job tomorrow versus the value of posting a vacancy. Then with probability, that's if the lambda, if x changes, right? With probability lambda. If the job is not destroyed, then x doesn't change. Then again, the employer compares the value of of a job versus the value of posting a standard. The employer gets the value of posting a vacancy. Now, I didn't go wrong. What is the value of posted job vacancy is minus k. This is the unit cost of posting and maintaining a job vacancy. And again, this is standard, guys. If the vacancy meets meets an individual job seeker and is not destroyed, then it compares the value of a job versus value of vacancy. Again, if the job vacancy meets an individual and it is not destroyed, then the probability 1 minus lambda, the x does not change. So again, the difference is that here x probability lambda has changed, here it's not, so you keep the same value of x. Okay, and then in the remaining events, you just get the value of...
Isn't that 0?
Well, I'm going to assume that the
It's an equilibrium condition.
yeah, I mean, I'm going to assume that v is 0.
That's what I understand when you have the V of omega prime on the right side. I don't know why causing a vacancy today, if and field has to do with causing a vacancy tomorrow.
But here, because I'm describing the problem of the individual agent before imposing equilibrium condition.
I see that, but I don't understand why you have V of omega prime there. As if causing a vacancy today gives you a particular entanglement about causing a vacancy tomorrow. I understand the question, everything is equilibrium condition implies 0, but in the integral, I don't see the max between J and B, which would be just J. That's a detail.
Okay.
That's a detail.
No, I didn't. So what is the value being employed? So the guy gets the utility 1 minus hx plus the after-tax wage income. And again, standard. So if the match is not destroyed, then the individual compares the value being employed versus the value being unemployed and the value being non-participant. Again, if the job is not destroyed and the individual keeps the same x, then again, it's just comparing the three values, keeping the same x. Okay? If the job is destroyed, then the individual has to choose, going back to your point, at each point in time, whether he wants to be unemployed or he wants to be out of the labor force. This is intuitive, and otherwise, again, if the job is destroyed and the individual keeps the same value of x, then again, he compares the value being unemployed and the value being non-participant, keeping the same value of x that he has currently. Now, what is, again, the value being unemployed? I think, guys, these Bellman equations they all share the same intuition. I just want to point out that the instantaneous return to the unemployed guy is the unemployment benefit plus the utility is 1 minus A times X. Okay, this guy is a searcher, right? So he's incurring the cost A of the value leisure, so he's classified as unemployed. Now, the value of being a non-participant, again, the instantaneous return, he gets the full value of leisure, X. Now, here, guys, the only intuition that I want to comment on is that you can see how with probability phi that shows up here, this guy, even though he's not participant and then is not paying the cost of search, with probability phi gets thrown into the pool of searchers. Once you do that, then he faces the same probability P to meet a job vacancy. Okay? Now, a nice property of the model is that, as Victor was alluding to, is that the model keeps this block recursive structure in a sense that you can determine the decision rule at tightness independently of the labor market stocks. Okay? So that gives you all the transition probability in this matrix. And then, of course, using those transition probability, then you have the recursion to simulate the stock of employment, unemployment, and non-participation. Okay. Victor, the only reason why I need the value, that stochastic property for lambda, is to get the co-movement of these two transition, the right co-movement with output of these two transition probability. Okay. Now, this transition volatility are not as volatile as the other transition probability. This means that much of the measurement that we do about the scar I was referring to, and the role of tax policy, is to some extent very robust, even though we don't get this right.
So when you look at the data, you look only at the volatilities of the states, of E, U, and N.
Both.
And why don't you look at the properties of the objects in the matrix?
No, I do that.
When you describe
Oh, I see. No.
isn't that an Which man is responsible for that?
we
And
can-
see whether the model is going to be.
We can do that. No, I agree. I think I didn't show you the property of this one just because it would take a lot of time, and to me it's intuitive the stocks, but I mean, I agree.
What is it that is giving you the block recursivenity? I thought you needed direct search to take that.
No, this is not. I mean, no, okay, sorry. Here, perhaps I'm using the wording block recursivity. I mean, even in the standard DMP, the fact that the tightness, you can determine the tightness independently of the stocks, I call that block recursivity.
It was already there before she amends it.
Yeah. Now, so the model has, so how much time do I have?
15.
Okay. So the model has 21 parameters. Now, I don't want to discuss all of them. I would happily discuss over the coffee or lunch. I just want to discuss these and get your feedback. Now, what is really important for the model is to identify the distribution of these leisure values of the individuals. That's because the mass of people at the margin between participating and non-participating, and it's key for the model to replicate the volatility of the participation rate and the average participation rate in the data. Okay? Now, lacking direct evidence about distribution of leisure values or home productivity, as David was pointing out, we do the following. Now, of course, this is a joint calibration, right? So the usual caveat applies. But what we do is that we use the mu of x, this is the mean or the log normal distribution of the leisure value as sigma x, to match the average participation rate and the volatility of the participation rate in the data. Okay? And then we're going to use the lambda bar. This is the mean probability that the value of leisure changes from one period to the next, and the volatility of that probability, so that the model gets the average of the transition probability of the probability of remaining employed, and the correlation with output of FEN. So this is if you think about it, this is a data puzzle. Because, as I said, what happens is that during booms, there are people that from employment go out of the labor force. Now, if you think about a model with aggregate shock, this cannot happen in the following sense. Aggregate shock that shifts productivity across the board up for everyone in the model, the incentives are either to stay on the job or to look for a job, and then because of vacancy posting, everyone gets up to employment. Okay? So you need this correlation between the technological process at home and the technological process on the market, so that to get enough people at the margin that during a boom they find optimal to get out of the labor force.
So how is that measured? Is it procyclical? The quitters are procyclical?
So FEN goes up in booms. Also FUN. So
This is you could have like individuals could save, and then if they become richer because there is a good shock.
I agree. Honestly, I had to say that I think I got convinced that more like what Jeremy was saying. I think that what is driving this correlation are really people that are not attached to the labor force.
Is it so then that the gross flows are getting so much larger? Because the N swings in expansion.
And shrinks in expansion.
N swings in expansion, so you have more people going from E to N, you have to have a lot more from N to E.
Yes.
Or from N to U.
Yes.
So it's a statement about the gross flows get
I mean, these flows are not very big.
They are not big. No, they're not.
They just go in the. These
No,
are small flows. These E to M flows are not big. We're not talking about lots of people going from employment to non-participation. And that's mainly women.
No, so those are young women that is less educated than the average worker. Yeah. So in a way, I'm sympathetic to the view that perhaps we should take more seriously the idea of household, a choice within the household, that to deliver a theory or somehow how the technological progress at home correlates with the technological progress on the market. So,
okay, sorry, go back. Since you put this picture, I mean, why do you restrict yourself to log normal? Why not take a flexible gamma and let the same number of parameters, because that shape is going to be critical. How many people you are going to scan?
Yes. No, we can do it. No, I think we've been lazy in a sense that everyone uses log normal, so I was induced to use log normal, but
gamma will deliver.
Yeah, no, I understand. No. Fair enough, Renzi. Yes. Yeah. So now, just to give you a brief intuition, the basics of the model. Think about the model. Take the calibrated model. So fix the parameters. This is the steady state of the model, conditional on productivity being equal to 1. Okay. Now, here I'm plotting on the horizontal axis x, the leisure value, and this is the density, okay, of people at x. Now, basically, the model features two cutoffs. There is a search cutoff. This is the blue one. Okay? So all people that are really productive at home don't search. Okay? People that are not as productive at home, what they do, they search. So these people are either unemployed already, or these are people that are now employed, but if they lose a job, they're going to search. Okay? And then there is a region here in the middle in which, here there are people that they are willing to work, but they don't want to search. I don't know, there is a literature that they call them marginally attached workers, but those are those people. Now here, what happens is that shocks to output are going to change this cutoff.
You have another cutoff for quitters?
I think this.
The capital value for a job that you will give up if you quit,
I think, Victor, here, if you are employed, the way the model is set up, you can only separate under a job destruction shock.
Also, it's later. So you are one of those that are pursuing this later.
No, okay, let's wait. No. So Victor, so I have another. Let's discuss. You know why? Because I have another paper where I show that endogenous separation are key to match some other asymmetry facts. I just wanted here to focus on the role of search friction and participation. I don't like slavery. So how does it work if the productivity? So just again to provide intuition. That's a recession, so it's a low value of y. There's an expansion, is high value of productivity. What you can see is that the cutoff move, but as you can see that intuitively, they don't move much. It must be the case, because if this cutoff moved a lot, then the model would deliver a completely counterfactual implication for the volatility of the participation rate. Okay? And you are fitting the model to match that volatility. Okay? So here, the search cutoff does not, basically barely moves. Yeah, barely moves. And is the other cutoff that moves in response to a positive shock. What you can see basically what's happening is that the people that would be non-participant no matter what shrinks, right, during booms and falls. What is expanding is the fraction of what I call marginal workers, in a sense that people that would be willing to work, but they don't want to incur the cost of search. So when I was saying that the distribution of leisure values is important, I was really thinking about this, in the sense that you really want to make sure that the mass of people around this cutoff is the one that delivers the right properties of the model.
So there's basically no force in the argument that, okay, if using the asymmetry in the job finding rates, if job finding rates are very low, I worry very much about getting a bad home production shock in the future, and to kind of insure myself against it, I go and look for a job right now.
So I had the same prior, because it makes sense. But when you feed the model to match the volatility of the employment to population ratio, the volatility and averages of participation rate, it seems to be the case. The model tells you that the property of the participation margin are pretty much insulated from the job finding rate. No, that's a quantitative statement. Of course, it depends on the job finding rate. But quantitatively, you can think of participation almost independently of the frictions of the labor market. But however, in order to understand the volatility of the unemployment rate, you cannot abstract from participation. And that is consistent with the finding of Ayşegül, Sain, Mike Esby, and others in their Jamie paper. Okay? Now, I have 10 minutes or less.
6.
Oh, much less. Okay. So here, guys, I'm going to show you. So I'm going to go fast on this. And this table summarizes just what I told to Ludo. Here, what I'm doing is that let's use the model to do a couple of counterfactual. Let's keep the same realization of the shock, both idiosyncratic shock and the aggregate shock. But let's simulate the variables fixing the market tightness ratio. It's column here. And the other way, letting the tightness ratio to vary in response to shock, but fixing the cutoffs. Okay. Here, the punchline is that if you look at the employment rate, guys, this is 1 minus the unemployment rate. It seems to be the case that even if when you fix the tightness ratio, okay, let's say you fix the extent of...
I understand what that means. Does that mean that you don't let firms enter, or you make firms enter against their will? That's a strange way. That's not a property. You're killing the economic condition of entering.
But no, so I'm making firm enter even though they would not like to do. That's... But that's...
Say that that's employment subsidy.
Okay, no, I can do that.
No, that's what they say.
No,
employment subsidy. What you're doing is an employment subsidy.
Yeah, so what I was aiming for is a way to disentangle the role. Of course, this is in equilibrium, so you cannot really do it cleanly. A way to disentangle the role of fluctuations in what I call frictions, as opposed to labor supply choices. So that's why I was simulating the model with the same shocks, but fixing tightness and see what is the volatility of the employment rate. And here I let tightness vary and I fix the cutoffs. Because in my mind I was thinking of the cutoffs is a margin of a labor supply. And here a margin that has to do more with frictions.
And the only thing that makes sense to me, if that's what you want to do, is to calibrate the model with the hiring cost.
Okay.
Rather than with matching function.
I think it's
And then that carries a meaning that you have, which is this hiring cost is inelastic.
So the punchline is that, as I was saying to Ludo, is that if you look at the employment rate, it seems that both frictions and cutoffs matter for the overall volatility. But if you look at the participation rate, actually it seems to be the case that it's all about the cutoffs. So there's a nice disconnect between what I think there are labor supply, the labor supply margin given frictions that is the main driver of the volatility of the participation rate. Now, if you look at skewness, I did the same exercise that Victor doesn't like much, but let's keep it the way it is. It seems to be the case that you see, guys, that when you fix two cutoffs and you let the tightness ratio vary, so these are frictions vary over the business cycle, you basically get the negative skewness in the employment rate. So it seems to be the case that the key driving force of the asymmetry in the employment rate that I was showing at the beginning is about how the tightness ratio and the extent of frictions changes over the business cycle. Okay? Actually, if you look at the participation rate, this is really cool, where you fix tightness, there's a sense in which if you only get the cutoffs vary over the business cycle, you actually would get a counterfactual implication for the participation rate. Because the participation rate in the data has zero skewness, in this counterfactual it will be largely negatively skewed. So there is a sense in which you need these interactions, equilibrium interaction between the level of the fluctuations in the tightness ratio and the cutoffs. Those generate offsetting forces that deliver the zero skewness, the lack of asymmetry in the participation rate. Now here, questions about this, guys? So here what I'm doing, so what is a scar? Here we measure scar as the difference between the average of a, so suppose you simulate the economy, and you calculate the average of a variable. The difference between that average and the median of the variable, we call it scar. Now, if you live in a linear model, of a log linearized model, what happens is that the median and the average must be the same.
The word scar in unemployment has a different meaning. It means the average loss of weight after a spell of unemployment. So if you're scarred because you had a job, you were making one, you lose your job, and then your next wage is going to be 15, 20% lower. That's what
Okay, here I'm using scar to see that recessions have permanent, negative permanent effects on the level of the employment to population ratio.
Isn't that fluctuation go back to steady state?
But the steady state, because the model is non-linear here. The average is different from the steady state of the non-deterministic steady state. So take this model, okay? Take exactly this model. Log linearize this model. You are completely right that fluctuations have no effect on the average.
So this is the difference between the mean of the employment rate in a world with zero solutions in output, and the sample mean you have that.
Yes. One. Okay. Oh, perfect. So what we do then, that's again, is the part of the paper that needs more work. So let's say that there is you can put in place a simple tax policy rule that you have a labor tax rate that goes up in booms and goes down in recession, and is symmetric though. Okay? So the ups and downs in the tax rate are symmetric as productivity. Now, of course, what you can see is that this rule is going to dampen fluctuations. Okay? Now, by dampening fluctuations, what happens is that scarring effect I was referring to is much reduced. Okay? Because here there is a connection, a tight link between the extent of fluctuations and skewness and what I was measuring as scar. Okay? Now, the sense in which policy like automatic stabilizer seems to be, in a non-linear world, seems to be important in terms of reducing the effect of volatility on the level of the employment to population ratio. Okay? Now, to conclude, what we did today, that volatility reduces the average level of the employment to population ratio, and the simple pro-cyclical labor tax rule reduces the scar by 70%, or also another predictions that if you have actually a lot of uncertainty in tax policy, suppose you have a government that are keep on changing tax rate that are related to business cycle, that uncertainty about tax policy adds to the overall volatility induced by business cycle, and that per se reduces the average level of the employment to population ratio.
The third bullet point seems out of the blue. Just go on, sir. Yeah, that's not in the model.
The third bullet point is a concept.
Speculative.
No, we have results. We have results that I didn't show you. But fair enough.
Reconvene at 11:20.
Okay.